Here is the note sheet for 5.8, analyzing graphs of polynomial functions. I sent it to you on PowerSchool. It's attached as a PDF. Basically, we're going to be looking at the polynomial in a little bit more detail. We've talked about the zeros, the factors, solution, the x-intercepts. Okay, now we're going to be looking at our turning points and what we call our relative extrema, often detailed as the local maximum or a local minimum. Okay, and it's viewed right in this photo here. Your local maximum is your highest y value in this little region here, or your local minimum, your lowest y value in this region here. Okay. Here is a little box for you to remember. The graph of every polynomial function of degree n. So let's say fifth degree, n is 5, has at most 5 minus 1 turning points. So a fifth degree could turn at most only 4 times. Okay. And then if a polynomial function has n distinct real zeros, so you graph it and it's a degree of 7, but it only crosses 3 times the x-axis, then its graph has exactly n minus 1 turning points. So if there was 3 real zeros, it will only cross twice. Or turn twice. Okay. All right, the calculator is your best friend here. Let's take a look at a couple examples. Let's go with number 2. It says graph the function, identify the x-intercepts and the points where the local maximums and local mins occur. So, because this is in factored form already, it's very easy to identify the x-intercepts. So if I do number 2 over here, you're going to have x equals 1. Okay, and notice it's a repeat, so it'll be bouncing off at x equals 1. And then this other factor will produce x equals 4. Now we got to go to the calculator and put this polynomial in. So give me a second here. Y equals, let me clear all this. And I got to be able to view it. So it's 2 parentheses x minus 1, close it down, squared. And then another set of parentheses, x minus 4. Okay, so there it is. Double check it. Graph. All right, so, looking at the polynomial, you got a x squared here times another x. So we have an x cubed if we were to multiply this all out. If we go back up to our little box here, we can see that this crosses once. Or it has 2 zeros, one at 1 and one at, I think that's 4. Oh, it has to be 4 from our problem. Okay, so that means if we go back to here, we are at 2 real zeros, so it's turning, if a polynomial function of n distinct real zeros, oh, we got 3 because of the repeat, so it's turning twice. There we go. I forgot about the repeat. So, how do we find these local maximums and local mins? This is where we use our calculator. Second trace, you just, again, do what you did with the vertex with quadratics. If I want to find the minimum, I'm going to use number 3. And I'll have a minimum down here. So I'm going to go find that. I want to be to the left of the minimum. So I'm watching that cursor. Definitely to the left. Hit enter. I want to be to the right of the minimum now. Hit enter. And then if you bound it correctly, hit enter for the guess. There we go. So our minimum, I'm going to write this down over here. Our local min, is when our x is 3, our y is negative 8. I think that's a negative 8 there. Okay. And then our maximum looks like it's going to be our repeat x-intercept. So when x is 1, our y is 0. And that should cover this point here. Okay. So there is one example from the note sheet. If I do number 4 now, I'll do number 4 in a box. Okay. This one I have to put in the calculator. So let's turn this off. And here we go. X to the 4th plus 3x to the cube minus x squared minus 4x minus 5. If I hit the graph, 1, 2. So this crosses twice. Okay, so we're at degree 4. At most, it could have 3 terms, according to our box. And you can see it turns once, twice, 3 times. And it's got 2 real zeros. So 2 minus 1, it has exactly 1 turning point. I'm not sure how that's making sense. Either way, we got to find our mins and our maxes here. So it looks like our zeros are -3 and maybe 1.5. So we got to find those. Second trace. So let's go find this one that was in between. So I got to be to the left of -1.5, or +1.5, sorry. Now to the right. And then, oh dear, that's an ugly one. So let's put it down. So we got a 1.42, 0. And I'm going to my table because it looked like it was at -3. Nope, you gotta go get that one. So back to the graph. I thought that was at -3. Second trace, gotta look for the 0. And we gotta be to the left of it. So left of -3. So I'm just moving left on the function. I'm definitely to the left of -3. Hit enter. Now I want to be to the right of -3. Hit enter. And ooh, that's why it wasn't on there on the table. It's unique. So I got a -3.07, 0. Okay, so there's my 2 zeros. And now I need to find the 2 mins and 1 max. So let's do that. Trying to put this in the same spot. Okay, so these are my zeros. And now second trace. Got to find the minimum. We're definitely to the left of that one. Go to the right, hit enter, and puts me way down there at the minimum. So I'll label this as a min. And the minimum is only the y coordinate, but the x that it sits at is -2.2. Might as well bump that to an 8. And a -9.61. So that's our local min. We also have another minimum, so I'll call it minimum again, and I'm going to go find that. That's right here. So back to the calculator. Second trace, we need to go to number 3, minimum, and I need to be to the left of that. So I'm watching the cursor, definitely to the left. Now to the right of it, hit enter for the guess. 0.67, comma, -703. Just rounded to the hundredths there. And then there's 1 max. And the max is going to be right there. So second trace. Number 4, the maximum. I have to be to the left of that. So that's definitely to the left. Go to the right. And if you bound it correctly, hit enter for your guess. And the maximum is just as beautiful, -0.65, comma, -347. That's all calculator work for this section here, gentlemen. And I'll talk to you soon.